Hello everyone, I am Neha Aprin. Welcome back to my YouTube channel. Today we are going to learn about Introduction to RAT compiler design and its phases. So what is RAT compiler? First of all, we'll learn what is RAT compiler. RAT compiler design is a crucial aspect of artificial intelligence development. It involves creating a specialized tool to convert source code written in a specific programming language into a set of intermediate machine instructions. This conversion is essential for enabling AI systems to interpret and execute the code efficiently. The design of RAT compilers efficiently impacts the performance and capabilities of AI applications, making it a key focus area for developers and engineers in the field of AI. So, the phases of RAT compiler design. The first phase of RAT compiler design is lexical analysis. In lexical analysis, there are three types: tokenization, error handling, white space handling. Tokenization. During lexical analysis, the source code is broken down into token including keywords, identifiers, and operators. This process involves recognizing the basic building blocks of the programming language, which are essential for further analysis and interpretations. Error handling. Lexical analysis also addresses error handling by identifying and reporting an lexical error, such as misspelled words or unrecognized symbols. This phase ensures the integrity of the source code before moving to the next stage of completion. White space handling. Another critical aspect of lexical analysis is handling white space, tabs, and line breaks in the source code. Proper handling of white space is important for accurately identifying the structure and elements of the code. The second phase of RAD compiler design is syntax analysis. In that, it's subdivided into phrasing, error recovery, and abstract syntax trees. Phrasing. The primary task of syntax analysis is phrasing, which involves analyzing synthetic structure of the source code to ensure the compliance with the grammar rules of the programming language. This process forms the foundation for subsequent analysis and transformation. So, but next is error recovery. The errors whichever we get in the program, it recovers in the syntax analysis. Error recovery. Syntax analysis include error recovery mechanism to handle syntax error in the source code. This mechanism aims to identify and recover from errors, allowing the completion process to continue with minimum disruption. Abstract syntax trees. One of the key outcomes of syntax analysis is the construction of abstract syntax tree, which represent the hierarchical structure of code. ASTs are instrumental in subsequent phases of completion and code generations. Phase 3 of RAT compiler designer. The semantic analysis is the third phase, in that it's subdivided into three: type checking, symbol table management, scope resolution. In type checking, semantic analysis involves type checking to ensure that the operations and expressions in the source code adhere to the defined data type and compatibility rules. Simple table management. This phase includes building and managing the symbol table, which is a data structure used to store information about the variables, functions, and other identifiers in the program. The symbol table facilitates effective semantic validations. The scope resolutions. Another important aspect of semantic analysis is resolving variable scopes to determine the visibility and accessibility of identifiers within the program. The fourth phase of RATCOMPILER is intermediate code generation. It is subdivided into two. The intermediate code generation phase involves transforming the source code into a simplified representation known as tree address code, which consists of instructions with at most three operands. Second, the control flow graphs are generated during this phase to represent the flow of control within the program, enabling further analysis and optimization. The fifth phase of RAT compiler design is code optimization. It is subdivided into three: constant folding, loop optimization, registration allocations. In that, first is constant folding. Code optimization includes techniques such as constant folding, which evaluates constant expressions at compile time to reduce redundant computations. Loop optimizations. Optimizing loops is a critical aspect of code optimization, aiming to reduce execution time and improve the overall efficiency of the compiled code. Register allocations. The process involves assigning hardware registers to variables and minimizing memory access, contributing to improved performance and resource utilizations. The sixth phase, the RAT compiler is having the sixth phase as code generation. It is subdivided into instruction selection, register allocations, code emissions. So first of all, we'll know what is instruction selection of code generation. The code generation phase involves selecting suitable target machine instructions based on the intermediate code and the target architecture. Whereas followingly, we learn register allocations. Register allocation strategies are employed to efficiently map variables and intermediate values to hardware registers and optimizing the performance of the compiled code. Code emissions. Finally, code emission encompasses the generation of executable machine code or assembly language code for the intermediate code representation and accumulating in the compilation process. So here we are at the end as conclusion and key takeaways. Comparative analysis. Each phase of RAT compiler plays a vital role in ensuring a comprehensive analysis and transformation of the source code. Whereas the performance impact of the RAT compile design, the design choice made during each phase significantly impact the performance and efficiency of the compiled code, making them crucial considerations. Continuous advancements. Rapid advancements in compiler technology continue to enhance the capabilities and optimization achievable in each phase during invocations in AI development. So I hope you guys got some knowledge by this PPT presentation. Thank you.